Welcome to the Scottparts YouTube channel. We are going to show you in this video how we go about refurbishing Scott conrods.
We'll take you through the process from start to finish of refurbishing the conrods, and please check out our channel, subscribe for more Scott related engineering.
So we're talking about Scott conrods here and the good and the bad parts of these and how we go about refurbishing them. So we're going to show you, for those that are not familiar with Scotts, the details of the conrods that we've got here. So we'll show you this, and what we can see here, the Scott conrod has a very large diameter big end, and it's relatively slender, as we can see. So the big end diameter there. These are slightly later rods. These are 3/8 of an inch wide. At the bottom end we have a nice kind of elliptical profile centre section of the rod into what we'd see as a more conventional gudgeon pin area with an oil slot in the top of it. This rod has a hardened eye set into the bottom of it, which is a press fit in, and then it's ground in place, and we have the bronze small end bushing, which is obviously common to pretty much all engines of that era. What we find is that Scotts suffer big end wear. It's one of the problems with the engines, and when it wears, what happens is that the top surface of the conrod here, it starts to become pitted, and obviously that's where the piston's pushing the rod down onto the crank while it's running after it's fired, and that area seems to always wear first. And once it gets more than a few thou of wear in it, it starts to rattle up and down, and it very, very quickly destroys itself. So what we've got to do is we replace the hardened rings in the bottom of the rod. The other thing we do is that the small ends suffer the normal kind of wear that you'd expect from a bronze bush. So we manufacture in-house and press fit them, but it's not like your normal BSA where you'd press fit it in and hone it the last couple of thou to get it right. One critical area of a Scott is the alignment of the bore that we've got on the big end there to the alignment of the gudgeon pin, and that's the alignment in this direction, and also the twist of the rod, which is in this direction. And the only way to be truly sure that your rods are right is to fit and grind the big end side of the rod, which we do. We then clamp it in a fixture, and then we line bore. So all of the gudgeon pin blanks that we supply are 14.5mm inside diameter, and then we line bore these to a couple of thou under 5/8 of an inch, 15.9mm, and then we hone it the last couple of thou to get the finish on it. And by doing that, by referencing off this bore of the big end to do the gudgeon pin, we know that regardless of the actual state of the rod, that we have a true bore. The other consideration with Scotts is that all the rods are different lengths. So officially there's a short stroke rod and a long stroke rod. Actually in practice you find out that long stroke rods can vary by up to a 1/16 of an inch in length. So obviously when you're rebuilding an engine, it's always good practice, as we do, is that by referencing off the big end bore again, is that we put the centre of the gudgeon pin exactly as it should be from the factory drawings, regardless of the actual rod length. So we know that the rods are straight, true, and the centre to centre distances are correct. And by doing that, this gives the best chance of your conrods and your big ends having the best life you can. Anything more than a couple of thou error in twist and bend, then you soon find out, because what happens is that when it's running, it pulls the rod across in the engine, and you end up running the rollers against one side of the side plates, which bows the side plates and creates a load of heat. You can usually tell that by blue coloured side plates. Or you start to run on the edges of the rollers and they start skidding, and very, very quickly you get big end wear. So this is a rod that's in for refurbishment that we've got here. First thing we do, press out the big end eye, press out the small end. I mean, what we find is that these eyes, if there's a little bit of wear in them, like a couple of thou of wear, and they're not too oval, you can actually regrind this slightly oversized, fit slightly oversized bushes on the cranks, and they'll be okay. You can rescue them. If it's more than a few thou though, you've got to put new rings in, and especially if they're oval. So what we do is we press the rods out, as we've done with this one here, press the rings out, and what we find is that this bore that we've got here is usually way off. It can be up to 10 thou, and of course if we press a new bearing ring into an oval hole, the bearing ring will, because they're about the same thickness, they'll end up with about the same amount of error in them, and that's not very good for making a good fit. So what we tend to do with the rods is that when we press the rings out is that we regrind this surface so it's perfectly true to the rod and it's actually round, and by doing that then we can make the bearing rings a nice press fit in. So what we're going to do now on these rods, we're going to go over to our cylindrical grinder, put the rod in the fixture, we'll clock it in, get the best fit that we can, bearing in mind that they're never round, and then we'll show you the process of grinding this eye round to start with. You'll actually see on this rod I've already pressed the blank gudgeon pin into this. Now onto the subject of the gudgeon pin bushes. 20.72 is our standard metric fit for these. It gives a nice press fit. I would define the nice press fit for these as you can do it one-handed on a vise. That's not one finger is too loose, and if you are using both hands and swinging on your vise handle it's too tight. You do find some rods that have a slightly looser fit, maybe they've been honed in the past, and we do some slightly oversized 4 thou oversized bushes for those as well, so we can supply those. So this rod now is ready for the new ring to be, the eyelet where the ring sits. We're going to grind that, and then we can measure it up and we can make the ring to fit. One other consideration with the Scots is that the gudgeon pin, as standard, the gudgeon pins are held in. There's a screw hole here, and they have a small screw that goes in, and actually what we do, my personal view, is that anything that has a screw in an engine has the possibility to also come out in that engine, and therefore you should minimise those as much as you can. If the gudgeon pin bush is the correct fit in the rod, it's my personal view that those screws are ornamental, they're not going to do anything, and therefore you're better off leaving them out, because then they can't fall out when the engine's running. So whenever we rebuild Scott engines, we leave those screws out, and I would recommend that you make the gudgeon pin bushes a correct fit, and that you also leave the screws out. I believe they're unnecessary. Right, on that, let's get this set up in the grinder, and let's make this round again. Here's an interesting point on a rod that had suffered big end failure, and I hope you can see this here. So there's been big end failure on this engine, and of course it's hammered up and down on the conrod here. Obviously it's hammered up and down like this, and what's happened is, because it's been hammering on the rod, the big end eye, there's actually a gap between the rod at this surface here and the big end eye where they meet. So this, we can't regrind this. Well, we can to make it round again and to rescue the surface, but what will happen is that we'll end up with a gap there. So the best thing to do here, because it's damaged the rod and it's bruised the material out, press the ring out, grind the rod round, and we'll put new rings in. So just an example of what goes on with Scots. Here we've got 6 conrods. I've just pressed the bearing rings out of these such that they can be renewed, and if we look at the inside surface of the rods that we've got here, I mean, this is just 6 rods that I've picked out of a batch, and I don't know the history of these, don't know which engines they've come from, they're just our old stock. And what we're looking for is, we're obviously going to regrind this surface, but these ones don't look too bad. There seems to be like an even pressure and colouring around the inside of there, and this is the bearing that came out of it. You can see there's some odd markings on it where it's not been touching symmetrically all the way around, but that's not too bad. This one here is very similar, which is the other pair for that one. They came out the same engine, so they've not been too bad. Whoever did those did okay. This here, somebody has ground the outside of this. These have never been run in an engine, I don't know where I got these rods from, but obviously somebody has refurbished these. I'm using inverted commas there. They've ground the outside surface of the rings here. It looks like they've definitely been done on a grinder. But of course inside the conrod we've got man's best bodging friend, Loctite, which I'm sure hopefully you can see on the video there. So obviously they've made the rings the wrong size, and to get around that they've Loctited the rings in, and that would have a life of about 5 minutes in a running engine. This is the other half of that pair, and again we can see that actually the ring looks okay where they've ground it, but again they've filled the big end eye with Loctite. So that first two pairs there, they were probably okay. Whoever had done those had done a good job. The second one, total bodge. This third pair that I've got here to show you, the rings on the outside diameter of these, we can see that it looks like they're a turn finish rather than a ground finish. And inside the rod, somebody has turned this rod in a lathe. We can see all the marks around it. We can also see that we've got water ingress between the bearing and the ring, so the fit hasn't been correct. But obviously a turned finish, it's quite rough, it's picked up, these rods are quite hard, and that's not the right way of doing this. Because they've got water ingress on one side of it, it probably implies that they'd ended up with a taper when they'd done it. And this final one of that pair is perhaps the worst of them all. So this is the ring that came out of that, and as we can see hopefully on the camera here, it looks like somebody has actually finished this with a draw file. So this hasn't been turned on a lathe, it hasn't been ground, somebody's filed it. So there was absolutely no way that that ring was going to stay round and stay in place inside that conrod. So it just goes to show you've got no idea of the history of these engines when you take them apart. And as we mentioned about different sizes for everything, the 6 rods here I've chosen at random from some rods I'm refurbishing, and all 6 of those are a different size by up to 15 thou on the ID of this ring, which again is why we can't just supply a replacement ring finished machined as a kit. So now I'm going to regrind all of these rods, the ID on all of these, and grind the OD of 6 bearing rings to suit each particular rod, press them in, and these will be as good as new, if not better.
Today and for a while now we're going to be turning this brass, this on stuff like that. Yeah, bronze, SAE 660 bronze, into these.
They're gudgeon pin blank bushes. We've got help from the workshop cat bar here. Let me go off and climb up something.
Oh, there we go.
So we've already programmed our CNC lathe here. It's all set up. We've got a length of bar in.
And it's the other one.
We've got a lot of conrods to do, which I'll show you a picture of. So while the machine's set up, we're going to make 30 or 40 of these, and off we go. Let's give it a go. This is our Jones & Shipman 540 surface grinder, and the process we're going to be doing here, these are our blank big end conrod rings, and what we're going to do is we need to grind them to width. Now these are quite critical on the Scotts. The width that these are usually ground to is a couple of thou less than the width of the rollers. That gives a nice fit on the engine and it ensures adequate clearance providing everything is aligned. So we'll go through the process. This is our 540 machine. Here's the grinding wheel. We have a magnetic bed. We set the end stops. We'll show you how we do that. It's fitted with the OptiDress kit that we've got here, and we use that to dress the grinding wheel so we get a perfectly flat wheel, and we also get a nice fresh cutting surface. So usually every few batches of these that we do, we redress the wheel and make sure that's still running right. So let's get things set up and running.
Yep, right size.
Okay, we've got one here, so this one hasn't been ground. All we've done is we've pushed or pressed the bearing ring out. We'll have a look at what we've got here. Let's go in and zero it. So in line with the rod, we've got our 0 point. Across the rod here. Bearing in mind we've done nothing to this rod except press the bearing ring out. That is 2.1 thou smaller. At 45 degrees is 2.6. 45 degrees this way, 0.4 bigger. So there's 3 thou ovality in this rod as standard, and obviously if we're going to try and make a bearing ring to fit that, what size do you make? But if it's already 3 thou oval, which is why it's best to do what we're doing here and start off with them round. This is our Jones & Shipman 1301 cylindrical grinder. This is what we use for doing all the bearings, conrods and such like that we do, main cups as well. We've modified the machine slightly ourselves so that it will take a full strut crankcase. So we're going to set this up. First thing we need to do is to dress the wheel. You can see here that we're just going to run this diamond backwards and forwards across the wheel, clean up the surface on that, then we'll clock in the conrod and we'll be good to go. So we're going to get this next one set up in the fixture. Put the rod in, make sure it's free, it's in the centre. We'll just lightly nip up the clamps, that's all we need. We don't want to cause any distortion in the part, of course. Yeah. Plop that in. best fit. Here we are set up in our fixture. So what we do is we've got this fixture, it's very accurately machined. We clean up the face of the conrod just by hand on a surface plate to make sure that there's no dimples and such like going to prevent the rod from sitting flat. We put the fixture onto a magnetic chuck that we've got here, and the purpose of the magnetic chuck is that it allows us to be able to centralise the rod as best we can. Because grinding is a very low contact, the mag chuck is perfectly okay for holding parts. So what we do is we put the part in, we've got a clock on here as you can see, and we will tap this around using a plastic hammer until we've got the best fit. And obviously we're dealing with oval parts here, so it always is a compromise. As we can see, this rod here, you know, we've got probably, it looks like a pretty square shaped rod, and we've got a total run out error on this of 6 thou. That's the best that we can get this because of the ovality. You know, so it's kind of typical sizes. And what we'll do now is that we'll grind that ID until it just cleans up all over, and that will leave the minimum amount of material removed, which obviously gives the rod a longer life. And then we can grind the OD of the big end ring to be a nice interference fit on that rod. So anyway, let's fire up the grinder and let's get this surface cleaned up. Anyway, that one's within a tenth of a thou again. I hope you can see the nice ground surface on there. We'll bring it up to the camera, hopefully it'll focus that far. And that'll be a nice surface for us to work on to be able to get new bearing rings in. Here's our conrods. So you can see what we've done here. We've pressed in our gudgeon pin blanks, as we saw earlier. We've pressed out the old big end rings from the eyelet. We've reground the eyelets on all of these so they're all round and true. So the next step is, you remember the bearing rings that earlier on we ground to width. What we're going to do now is, obviously every one of these is a different size now, so we're going to measure each one of these in turn, and then we're going to grind the outside diameter of these bearing rings to be an interference fit with each of these rods and press them in. That's the next stage of the rod refurbishment. So let's get these measured get the measurements written down and get the fixtures set up on the grinder to be able to grind these. We're back at our cylindrical grinder now. You might notice that we've changed the workhead round because now we're going to do the outside diameter of the bearing rings. Previously we were doing the inside of the conrods. So we've turned the workhead round on the grinder here, so we're going to use the big wheel. It rotates a lot slower than the small one, and this wheel is obviously suitable for doing outside diameter work. We've changed the fixture that we've got in the head here. We've changed this over to the fixture. We actually use the same fixture for doing main cups as well, but in this case we've mounted the fixture onto our mag chuck again. We've got our bearing ring mounted in here, which you can see here, and we're going to be able to ground the outside diameter, and we'll run the batch through with the correct interference fit to suit all of the rods that we've just measured. First job, we've changed the wheel. Because we've changed the workhead round, we've got our diamond dresser in here. We're going to dress the wheel to make sure it's perfectly parallel with the bed, and also it gives us a fresh surface on the wheel again, which gives us a better quality Another one done. Good part. We're back at the bench. We've got our rods. We've ground the ID. And we've got our bearing rings. We've ground the OD on these and the width already. So now these are matched pairs. Next job, we're just going to dress a very small chamfer on the outside of this. We're going to put some notches in for dot punches, and then we're going to fit them with the press. The purpose of that chamfer is that if we have a very sharp edge where we've ground both surfaces, basically it'll act like a knife and it'll scrape the inside of the rod. So it only needs just a very edge break in there on the side that's going to go into the rod. But there we are, it's done. Let's put some notches in these. And typically what I do is I put 3 notches on each side for the dot punches. So you just mark with a pen, 3 on that side, and then we go in effect 60 degrees round and mark 3 on the other side, and that gives us our marks that we're looking for. And I can use those as a guide on the grinding stone. You'll be able to see here a close-up of those notches that I was talking about. So we've got 3 on one side, 3 on the other, and you'll see later on that we use those just to put a small dot punch on the rod, which adds further security. And in fact you can see on this rod here evidence of previous dot punchings on both sides of it. So you'll see that process shortly. Here we are over at the press. We've got our ring. We're going to press it in chamfer side downwards into our conrod that it's a matched size for. We're just using a brass block to go on top of the bearing to press it against. Lay the rod into the press, make sure that the small end side of the rod being bigger isn't on the same metal bar, because otherwise we'll get a very bent rod. So we hang the rod over the side of the plate like this, assemble it up, and it should press in very nicely. There we are, there's our bearing ring in the rod. Nice job. So remember those 3 centre punches we put in earlier on each side, also the centre punch recesses we put into the bearing rings. Now we're going to use a very sharp centre punch, small sharp one here, and we're just going to put a small dot mark onto the rod to line up with each of those, and that'll help secure the rod in place. So we're just going to lay the rod onto the vise here, so we've got a nice solid base, and put these dot punches in. On the other side, there we are, centre punches in that one. Let's do the other one. Now there's a couple of things we're pressing these rods in, and also dot punching that we've got to be careful of. The first thing is that the rings we've pressed in are a couple of thou wider than the conrod. So what we need to do is actually we need to centralise that ring on the rod so that if it touches a bearing plate, it's actually the hardened ring that touches and not the edge of the rod. The other thing is that where we've dot punched those, it'll have upset the metal slightly upwards. So the next couple of jobs to sort this rod out are to just rub it on a surface plate with a bit of carborundum, wet and dry paper, to make sure that we've got a perfectly flat surface. And we need to centralise that ring in the rod, which we do because it's only a couple of thou. You can do it by feel, and you can just run your fingers over it and work out that it should be proud, a thou or two on each side, and if it isn't, it's a quick tap with a hammer to adjust it. So we'll do that on these 2 rods, and then we're getting somewhere with these.
So this is our conrod so far. We've pressed this little end and the big end out of it. We've put a blank little end in, and we've ground the inside diameter of the actual conrod so it's actually round. We've done the width and the outside diameter of the big end ring, fitted it, and that's all we've done so far on these. Thank you for watching part 1 of the conrod video. It's turned into quite epic, so we've decided to cut it in 2 parts.
Yep, please join us in part 2 where we'll finish off these conrods and we'll fit them onto big ends, and you'll be able to see how we do that. See you soon.